All right, let's dive into a world where stuff can fix itself.
Yeah,
We're talking self-healing materials. You've been asking about this stuff.
it's pretty cool.
And let me tell you, the reality is even cooler than the sci-fi. Think materials that can patch themselves up, just like our skin,
Hmm.
extending their lifespan,
Yeah.
minimizing maintenance.
Yeah, we're basically taking inspiration from nature's best and
Yeah.
applying it to everything, from airplanes to everyday objects.
Exactly. And for this deep dive, we've got a really cool mix of sources, excerpts from academic papers, even a student's overview, and even a glimpse into what Airbus is doing with self-healing tech in their planes.
Oh, wow.
So let's get into it. First things first, we've got two main types of self-healing, intrinsic and extrinsic.
Yes.
Yeah.
And that's where the link to nature gets really interesting. Intrinsic healing means the material itself has the power to fix damage. It's built in, like our skin regrowing after a cut.
Right.
Extrinsic healing, on the other hand, relies on added healing agents, kind of similar to how our blood clots to stop bleeding. Both are pretty incredible, and we're seeing scientists exploring both avenues.
Okay, I'm already intrigued. But how does it actually work? What's going on at the molecular level that allows these materials to fix themselves?
Well, with intrinsic healing, one method is through reversible chemical bonds. Imagine these bonds are like tiny pieces of Velcro. At the molecular level, they can break apart when damaged, but then reattach under the right conditions, effectively healing the material. A great example of this is the Diels-Alder reaction.
Diels-Alder reaction. That sounds pretty complex.
It is.
Can you break that down for me a little bit?
Absolutely. Think of it like two molecules fitting perfectly together, like puzzle pieces, forming a strong bond. But what's remarkable is that this bond can be broken and reformed by applying heat, kind of like melting and remolding plastic.
So it's like mending a crack in a plastic toy with a hairdryer.
That's a perfect analogy. That's actually another example of intrinsic healing, called thermoplastic healing, where polymers soften with heat and fuse back together.
That's pretty amazing.
Yeah.
So what about extrinsic healing? How do those healing agents get to where they need to be?
There are a couple of ingenious approaches. One involves microcapsules. Imagine tiny capsules, like microscopic bubbles, embedded throughout the material. These capsules are filled with a healing agent, and when damage occurs, they rupture, releasing the agent right where it's needed. Think of it like a network of mini first aid kits, strategically placed within the material, ready to deploy at a moment's notice.
That's pretty slick.
Yeah.
But what if the damage is more extensive than a minor scratch? How would those tiny capsules handle larger scale damage?
That's where vascular networks come in. Imagine a network of tiny channels, like blood vessels, running through the material. These channels are filled with a healing agent that can be transported to larger areas of damage, ensuring comprehensive repair. It's a more complex system, but it has the potential to tackle more significant damage.
So you got microscopic Velcro, built-in first aid kits, and even tiny plumbing systems, all inspired by nature. This is incredible.
It really is.
And when it comes to those microcapsules, what are they made of?
A common example uses a healing agent called disilopentadine, or DCPD, along with a special catalyst called Grubbs catalyst. When the capsules break open, the catalyst triggers a reaction that causes the DCPD to rapidly polymerize, effectively sealing the damage.
Wow, so it's chemistry.
Yeah, it's a fascinating example of how we're harnessing chemistry to create self-healing capabilities.
Okay, my brain is officially doing backflips. We've gone from the general idea of self-healing to actual chemicals and catalysts. But before we get lost in the chemistry, I want to talk about specific materials. We've got research on metals, composites, even concrete. Where do we even begin?
Metals are a good place to start.
Okay.
Now, you're probably familiar with aluminum. It's everywhere.
Right.
But what you might not know is that it has some inherent self-healing properties thanks to the oxide layer that forms on its surface.
Right. I know aluminum forms a protective layer
Right.
when exposed to air, but you're saying that layer can actually heal damage.
Exactly. Small scratches and damage to the aluminum surface can actually heal over time as the oxide layer reforms, effectively sealing the exposed metal from further corrosion. It's not as dramatic as some other self-healing mechanisms, but it's a great example of how even common materials can exhibit some level of self-repair.
Okay, that's pretty neat. But aluminum isn't exactly going to regrow a missing chunk, right?
Right. But there are some more exotic metals that are being explored for their self-healing potential.
Oh, really?
One that really caught my eye is gallium. It's a metal that's liquid at room temperature.
Wait, liquid metal? That sounds straight out of Terminator 2.
It does, and its unique properties make it incredibly interesting for self-healing applications. especially in flexible electronics and even batteries.
So we could have phones that can repair their own circuits.
Potentially. And that's just one example. Gallium's flexibility and connectivity make it a really promising material for a whole range of self-healing applications.
That's mind-blowing. But what about applications on a larger scale? I'm thinking bridges, airplanes, things that need to be incredibly reliable. Isn't that where composites come in?
Absolutely. You're right on the money there. Composites, which are basically combinations of different materials, are incredibly strong and lightweight. That's why they're used in everything from airplanes to wind turbine blades.
Right.
And researchers are making huge strides in developing self-healing composites.
So this is where that Airbus research comes into play. They're actually using self-healing materials in their planes.
That's right. They're utilizing thermoplastics, those materials we talked about earlier, that can soften and fuse back together with heat. It's a perfect solution for repairing those tiny cracks.
Yeah.
That could potentially become major problems down the line.
So if a small crack appears on a plane wing, it can basically heal itself before it becomes a safety issue.
It is.
That's impressive.
And it highlights one of the most significant advantages of self-healing materials, enhanced safety.
Right.
But that's not the only benefit.
I imagine it would also significantly reduce maintenance costs and extend the lifespan of these materials.
Exactly. And by extending the lifespan, we're also reducing waste, which makes these materials more sustainable.
Okay, good.
But of course, there are still some challenges to overcome.
Like what? Is it difficult to get these materials to heal efficiently?
That's one of the biggest hurdles. Some materials take quite a while to heal, which isn't always practical. It's a balancing act. Sometimes you need speed, sometimes durability is more important. And then there are the environmental factors. Heat, cold, pressure, all of these can impact the healing process.
And I'm guessing cost is a factor too. This stuff can't be cheap to produce.
You're right. Self-healing materials are still relatively expensive to manufacture, which is one reason why they haven't been widely adopted in consumer products yet. But as research progresses and production methods improve, those costs are expected to come down.
Okay, good to know. So what does the future hold for self-healing materials? What are researchers working on right now?
Well, there's some really exciting developments on the horizon. For instance, researchers are exploring how to utilize 3D printing to create objects with built-in self-healing capabilities.
Wait, 3D printing self-healing objects. You're blowing my mind again. Tell me more about that.
Imagine being able to print a phone case that can repair its own scratches, or a bridge beam that can mend its own cracks. That's the kind of potential we're talking about.
That's incredible. What else is in the works in the world of self-healing?
Another fascinating area is stimuli-responsive healing. Imagine materials that can heal on demand, in response to light, pressure, or even electricity. It's like giving materials a sense of awareness, allowing them to actively respond to damage.
So instead of just passively healing, these materials can be actively triggered to repair themselves.
Exactly.
That's amazing.
We could design materials that heal faster under specific conditions, or even materials that can adapt their properties in response to damage. It opens up a whole new realm of possibilities.
This is all so fascinating.
Yeah.
But I have to ask, are we considering the environmental impact of these materials? Sustainability is a big concern these days.
Absolutely. You're right to bring that up. And researchers are actively looking for ways to make self-healing materials more sustainable. That includes using biodegradable components and developing manufacturing processes that are less energy intensive.
So we could potentially have self-healing materials that are not only incredibly functional, but also environmentally friendly.
Precisely. It's about finding solutions that are both innovative and responsible.
Okay, this has been an amazing journey so far, and I can't wait to see where it all leads. But before we get too carried away with the future, let's take a moment to recap what we've learned so far. You've shared a lot of information, and I want to make sure I've got it all straight.
A recap is always a good idea. It helps solidify the key takeaways.
All right, so we started by talking about the two main types of self-healing. Intrinsic, which is like the material having its own internal repair crew, and extrinsic, which involves adding those special healing agents. And we dug into specific examples of each type.
Yes, we did.
Intrinsic healing can involve those reversible chemical bonds, like in certain polymers that can rebond when heated, or thermoplastic healing,
Right.
where materials soften and fuse back together with heat. And for extrinsic healing, we explored those fascinating microcapsules filled with healing agents that burst open when damage occurs, as well as vascular networks, which are like tiny pipelines that deliver healing agents to specific locations. It's amazing how scientists are taking cues from nature, things like blood clotting and skin regeneration, to create these incredible technologies.
Absolutely. Nature has had billions of years to perfect these processes, so it makes perfect sense to learn from the master.
Right.
And we've already seen how these principles are being applied to real-world materials.
Like aluminum, which can form that protective oxide layer that heals minor scratches. And gallium, the liquid metal with its potential in flexible electronics.
And we can't forget about those incredible composites, which are playing an increasingly important role in industries like aerospace and construction. Remember, Airbus is already utilizing self-healing thermoplastics to repair minor damage in their planes.
It's mind-blowing to think that this technology is already being implemented in such critical applications. It's a testament to how far the field has come. But of course, there are still challenges to tackle.
Yes, healing efficiency and cost are still major hurdles. Some materials take a long time to heal, and the manufacturing processes can be quite expensive. But research is constantly pushing the boundaries, and as technology advances, we can expect to see these challenges addressed.
And the future of self-healing materials looks incredibly bright. We touched on 3D printing self-healing objects, stimuli-responsive materials that can be triggered to heal on demand, and the development of more sustainable and eco-friendly materials.
The potential applications are practically limitless. Imagine a world where potholes repair themselves, clothes mend their own tears, and electronic devices fix their own glitches. It's a future worth striving for.
It sounds like science fiction. But it's becoming increasingly clear that this is the direction we're heading in. Self-healing materials are poised to revolutionize the way we design, manufacture, and use products in virtually every industry.
And the most exciting part is that this is still a relatively young field of research. There's so much more to discover, and the possibilities are only limited by our imagination.
We've covered a lot of ground in this first part of our deep dive into self-healing materials, but there's still so much more to explore.
Welcome back to our deep dive into self-healing materials. I hope you're ready for more, because we're about to explore some cutting-edge research that's really pushing the boundaries of what's possible with this technology.
I'm definitely ready. Part one already blew my mind.
Mm-hmm.
And you mentioned something about bio-inspired approaches and nanotechnology. What's happening in those areas?
Well, as we've seen, nature is a masterclass in self-healing, so it's only natural that researchers are looking to biological systems for inspiration to create even more advanced self-healing materials.
That makes sense. Nature has had billions of years to perfect these systems.
Exactly. For example, scientists are studying organisms like starfish and lizards, the ones that can regenerate entire limbs. They're also looking at how plants repair damage to their tissues.
Wow.
By understanding the biological mechanisms behind these processes, we can potentially develop materials that can mimic these amazing abilities.
So we could have materials that not only heal damage, but actually regenerate lost parts.
Yeah.
That sounds like something straight out of a science fiction movie.
It does, doesn't it? But the reality is, it's not as far-fetched as it sounds. And this is where nanotechnology comes in. By manipulating materials at the nanoscale, which means at the level of individual atoms and molecules, we can create structures and properties that can significantly enhance self-healing capabilities.
Okay, help me wrap my head around this nanoscale concept. We're talking incredibly tiny here, right?
We are. Imagine a world 1 billion times smaller than a meter. That's the nanoscale. And at that level, materials can behave very differently, and we can exploit those differences to our advantage. For instance, researchers have created self-healing coatings using nanoparticles that are designed to release a healing agent when they detect damage. It's like having an army of microscopic repair robots constantly monitoring the material, ready to spring into action the moment damage occurs.
Wow. So it's like having a built-in invisible repair crew working around the clock to keep things in top shape.
Exactly. And because we're working at such a small scale, the healing process can be incredibly precise and efficient. Nanotechnology also allows us to enhance the strength and durability of materials, which is crucial for many applications.
This is all so fascinating, but I'm also curious about the practical applications. What kind of real-world problems are we tackling with self-healing materials right now?
Well, as we mentioned earlier, the aerospace industry is a big adopter of this technology. Airbus, for example, is already using self-healing thermoplastics in their planes to repair minor damage to wings and other components. This not only increases safety, but also reduces maintenance costs and the amount of time planes are out of service.
Right, so it's a win-win for both safety and efficiency. What about other industries? Where else are we seeing self-healing materials making a difference?
Self-healing concrete is another exciting area. Traditional concrete is prone to cracking, which can compromise its structural integrity and lead to expensive repairs. But by incorporating self-healing agents into the concrete mix, we can create structures that can essentially repair their own cracks, extending their lifespan and reducing the need for costly and time-consuming maintenance.
So we could have bridges and buildings that can heal themselves. That's a game changer for the construction industry.
Absolutely. It has the potential to revolutionize how we build and maintain our infrastructure. And it's not just limited to large-scale structures. Researchers are also developing self-healing coatings for everything from cars to electronics. Imagine a car that can repair its own scratches, or a phone screen that can fix its own cracks. No more unsightly scratches or expensive repairs.
That would be amazing. And it seems like there are a lot of potential applications for this technology. Beyond just structural materials, are there any potential medical uses for self-healing materials?
You bet. The medical field is actually one of the most promising areas for self-healing materials. Researchers are developing self-healing hydrogels for wound dressings. These dressings can promote faster healing and reduce scarring. They're also exploring self-healing materials for implants and prosthetic devices, which could significantly improve their longevity and performance.
Wow. So we could have self-healing bandages, artificial joints that repair themselves, and even prosthetic limbs that can adapt and grow with the user.
Exactly. It's all about creating materials that can interact with the body in a more harmonious way. And we're really only just scratching the surface of what's possible. As research continues to advance, I think we can expect to see even more innovative and transformative applications of self-healing materials in healthcare and beyond.
It's truly incredible to think about the potential of this technology
Yeah.
to revolutionize so many aspects of our lives. But beyond these specific applications, what kind of broader impact do you see self-healing materials having on our everyday lives? How do you think this technology will change the way we live and interact with the world around us?
I think self-healing materials will eventually become so commonplace, so integrated into our everyday lives, that we won't even think twice about them. They'll be seamlessly woven into the products we use every day, quietly working behind the scenes to make our lives safer, more convenient, and more sustainable.
So we'll be like having this invisible force field protecting our things,
Yeah.
silently fixing damage and keeping everything running smoothly.
Exactly. And it's not just about convenience. Self-healing materials also have the potential to significantly reduce waste and resource consumption. If our products can repair themselves, they'll last longer, which means we won't need to replace them as often. This could have a profound impact on the environment, lessening our reliance on raw materials and reducing the amount of waste we generate.
It's amazing to think that this kind of technology could have such a huge impact on our planet. It's a great reminder that innovation doesn't always have to be flashy or complicated. Sometimes the most elegant solutions are those that are inspired by nature and designed to seamlessly integrate into our lives.
Absolutely. And that's what makes self-healing materials so exciting. They represent a perfect blend of scientific ingenuity and nature's wisdom. We're essentially taking these brilliant natural processes and adapting them to create a more sustainable and resilient future for ourselves.
This deep dive has been an incredible journey so far. I've learned so much about the science behind self-healing materials, the fascinating applications that are emerging, and the vast potential of this technology to reshape our world. But before we wrap up, I have one more question for you. What do you think is the most exciting or promising development in the field of self-healing materials right now? What's got you particularly fired up?
That's a tough one. There are so many amazing avenues of research being explored right now, and it's hard to pick just one. But if I had to choose, I'd say the development of self-healing materials that can respond to multiple stimuli is incredibly exciting.
Okay, tell me more about these multi-stimuli responsive materials. What makes them so special? Okay, tell me more about these multi-stimuli responsive materials. What makes them so special?
Well, imagine a material that can heal itself in response to a combination of factors like heat, light, pressure, or even specific chemicals. That's what we're talking about here. These materials can sense and respond to their environment in a much more sophisticated way, enabling them to adapt and evolve to meet specific demands.
So instead of just passively healing, these materials can actively respond to damage in a targeted way based on the specific conditions they're exposed to.
Exactly. It's like giving materials a sense of awareness, a way to interact with their surroundings and adapt accordingly. This opens up a whole new realm of possibilities for designing materials that are not only self-healing, but also incredibly versatile and resilient.
That's an incredible vision. It sounds like we're on the verge of a materials revolution, where materials are no longer just passive building blocks, but active participants in their own repair and evolution.
I think you're right. Self-healing materials have the potential to completely change the way we design, build, and interact with the world around us. It's a paradigm shift in the way we think about materials.
This deep dive has been an absolute eye-opener. I've learned so much about the science behind self-healing materials, the amazing applications that are emerging, and the sheer potential of this technology to change our world for the better. From those microscopic Velcro bonds to those tiny self-healing robots on the nanoscale. It's all been incredibly fascinating.
It has been a fascinating journey, and I'm glad you found it insightful. Remember, this is just the tip of the iceberg. The field of self-healing materials is constantly evolving, with new discoveries and applications popping up all the time.
Exactly. So if you're intrigued by all this, as I know I am, don't stop here. Keep that curiosity going. Dive deeper into specific types of self-healing materials, explore the research, or even imagine how you might contribute to this incredible field. Who knows? Maybe one day you'll be the one making groundbreaking discoveries in self-healing materials.
Absolutely. The possibilities are truly endless.
And on that note, we've reached the end of our deep dive into the world of self-healing materials. We've covered a lot of ground, from the basic mechanisms to the mind-blowing possibilities.
But remember, this is just the beginning. The future is self-healing, and it's going to be amazing to see how this technology continues to shape our world.
I couldn't agree more. Thanks for joining us on this incredible journey.